Yeah.
Yeah. Okay, so today we're gonna start a new units, which is log, and it's not really useful for in life, but it's really useful for the knowledge that you learn in like in future. So it's really important also. So yeah, let's
Okay,
start.
yeah. I cannot go to the next slide now.
Oh,
Like, how do
really?
I go to? Yeah. Hold on, I have
No.
to stop share. I can do it this way. Here, let me show you. I can do it without presenting. Okay, next slide. There.
Liz, do you want to go?
Oh, sure.
Yeah.
Okay, so the definition of log. Usually when we talk about log, you can also think about exponents because they are related to each other. So a logarithm is a mathematical function denoted as the inverse of an exponential function, and each logarithm has a base, argument, and an exponent. So right here, you can see this picture here. The base is this a, the argument is the y, and then the exponent is the x. Well, the variables can change, but here's just what you'll see. And then if you have log b of a equals c, it means that the base times the to the power of the exponent will be your argument. So it's just a simple expression that you just have to know. Okay. So here are some basic graphs. You don't really have to know really much about it, but here you see a logarithmic graph. It goes this way, like it approaches either the y-axis. Yeah, it approaches the y-axis. Basically, it goes this way. And in an exponential graph, it approaches the x-axis. So it goes horizontally and it goes up. But here it goes vertically and it goes to the side. Yeah. Okay. Um, Yifan can go over this slide with you guys.
Okay, so what does this graph tells us? Okay, so the graph of this function is over here, which is log a of x, that a is greater than 1, and it tells us that, well, I mean, there are different numbers like 2, 10 for letter A. So all three functions go through y0. The coordinate of 1 is 0, which means that all log logarithmic logarithmic equation will pass through coordinate 1, 0, and all three functions, they are concave down of, and all three functions are reducing their slope as x becomes bigger, and they are negative when x is less than 1 and greater than 0, and they all three functions are increasing, as you can tell. Yeah. Here's the another form of graph, which the a is less than 1 but greater than 0. A cannot be negative, right? Yeah. Well, it doesn't matter. Okay. So all three function will pass through 1, 0. 1, 0 is yeah, it's like the last one. It's like the one with a greater than 1, and all three function concave up, which is like the opposite direction of the other graph, and all three functions are reducing as they slopes. All three functions are reducing their slopes as x become bigger, and they are positive when x is greater than 0 and less than 1. All three functions are decreasing. Yeah.
Okay. Tracy, do you want to go over this one?
Yeah. So now we're starting a very basic like what do you call it, chapter knowledge. So log to exponent form. So basically sometimes like normally you see log form like this. So log base n yeah. So an example is let me change the color. It's like log base 2 and 3. It's just a simple example. And then we want to change to exponent form. So you oh, okay. So a is a power. It's supposed to be like here, right? I think. I already forgot what I learned. But oh, no, never mind. Sorry. Oh, so it's supposed to be log base 2, 3 equal to whatever, like you set for 5. And then, so you change. I think what I learned is like this. You draw a E right here. And then it's supposed to be 2 to the 5 power equal to 3. So the E goes like 2, 5, 3, and then it's just like this. But yeah. Okay, so we can try like 2 questions together, and then the rest of 2 we can do it by ourselves. So let's do first one together with Liz.
Okay, so for doing these problems, you kind of need some basic knowledge on exponents. Like, you have to know what's 2 to the third power, or if you have a calculator, that'll be fine too. But as you do more of these, you'll get used to them, so it's okay. So using the formula we know before, we have log base 3, right? Because this is the base. And then, God, I forgot the other thing called. Hold on. That's the base. And then here, wait, what? Hold on. Sorry, guys. Okay, yeah, and here we have the argument. And then here we have the exponent. Yeah, it's really ugly, sorry. So if you change it into exponential form, you will have 3 to the 4th power equals 81. So that'll be how you do it. And then let's look at another one. So this one's kind of easy because you will know that any number to the first power is that number. So 7 to the first power equals 7. Yeah. Okay. You guys can try the last 2 by yourself.
Yeah, Ethan, do you want to go over last 2 since it's pretty quick and easy?
Okay, so for number 3, the answer to exponential form is 14 to the power of 0 equal to 1, because everything to the power of 0 will equal to 1, and in this case it makes sense. And for number 4 is 1/2 to the power of -5. equal 32. Which is like, okay, so when it's to the negative, it means it's the reciprocal, right? Or like you have to switch them. So it's also mean 2 to the 5. Oh my god. 2 to the 5 power, which is also 32. Yes.
Okay, so we just have more practice problem because practice makes perfect. And these are really easy because it already gives you the answer. So you just have to convert them and then we'll come back in 2 minutes.
Okay, so let's check answer together. Yeah. So it's already showing right here, but you can check your answer like with the whatever it shows on board.
All right, so something to note over here is that on number 2, you see it's 289 to the 1/2 power. Anytime you see if it's a fraction up there, it also means it's a square root. So you can also rewrite this as square root of 289, right? So just so you know. And on number 3, the exponent is it's a negative number over here. And as Ethan said before, it's the reciprocal. So when you have that, if you just write it out, it's like that. But when you have a negative, you have to put it 1 over 14 squared, right? So that will come to the bottom, and then that's how you get a fraction. Whenever you see a negative, you have to put the reciprocal, and then the negative sign goes away. Yeah. Okay. How do I clear screen?
Let me do it. It's okay. Okay. So right now we're gonna do exponential form to log form, which is just switch up to the previous question that we did. So what I do is also the E thing. So you do log base 64 8 equal to 1 over 2. So that is how you change to log form. And then same thing as here. You do the E thing. So first you went to 12, second you went to 144, and then third you went to the exponent 2. So it will be log 12, base 12, I mean. To 144 equal to 2. So yeah. And then I think you guys can try 7 and 8 by yourself, and then we can check answer after you're done.
Wait, Tracy, can you pause the recording for a second?
Yeah. Okay, so I hope you guys already done 7 and 8. So Liz, do you want to go over the answer?
Sure. Okay. Yeah. Now I'm going to show the answer. I'm not gonna do it. So this one, if you, I think Tracy's trick is like really nice. So right, you do an E, right? So first you reach to 9, so log base 9, and then you get to 1. Oh, yeah. And then you get to 1 over 81, and then that's equal to -2. So here you see another negative exponent, right? Remember you have to put like 1 over 9 to the second power, right? Which you get 1 over 81. And then over here we have a fraction one. So this, if you do the E again, it'll be like that. So it's log base 1 over 12, and then 1 over 144 equals 2. Yeah. So that's it. Okay, next slide. So these, we don't have the answers anymore. You just have to evaluate them. So you're not changing them into whatever form, right? You're just evaluating them. So you kind of have to know some basic knowledge. Just take your best guess or use a calculator. It's okay. But all you're getting out of here is a number. So for example, number 21, right? All you'll get is 3. 3, right? Because 4 to the third power equals 64, right? So you're getting like whatever it's equal to over here, right? So you just have to solve it. Okay, I'll give you guys like 5 minutes to do this because I don't know if you guys know this right away.
Yeah. So what about let's do one more together? Since so you also do the E thing. E is like a lot, so you can use E like whenever you want. So 6, like, so first you set to like equal to x since you want to solve for x, and then 6 to the x power equal to 216. 6 to the x power equal to 216. So you got x equal to 3. So yeah. Oh, just add on. You can use a calculator if you want. So. Okay, so I think Ethan can go over like 23 to 25. And if you are like not done yet, please pause the video and then finish your like answers and then we can check answer together. So yeah, go ahead.
Okay. So for 23, we can set a variable first at here and equal to 16, right? And I'll teach it in another way. And if you get, you can, okay, so you should sample make the right side into same base if you know what's the basis. And in this case, it's 4 to the square, 4 square equal to 16. And you'll get x equal to 2, which is the power equal to 2. Yeah. And for number 24, it's the same thing. Oh, wait, what's the answer for this one?
-5.
-5. Okay. So x will be -5. Oh yeah. 5. Okay. And for this one, it's the same thing. So 5 to the power of x equal to 125. And 5x equal to 5 to the power of 3, and x equals to 3. Yeah. Okay. And and for 26, we got 2 to the power of x, and this one's easy because like isn't 2 to the power of 2, people just memorize it, and so x equals to 2.
Yeah, and then going on for 27. So 343 to the x power equal to 7. And then x equal to, I believe, is 1/3. So 1/3. Next one, 2 to the x power equal to 16. X equal to 4. And then the last one, 64 to the x power equal to 4. X should be 1/3. So make sure you check your answers. Cool, we can moving on. Yeah.
Okay, so these are rules of logarithms. These you just have to get them stuck in your mind. Like same as the exponents, you just have to know them because when you solve for harder equations that you will see later, you have to use these or else you cannot simplify. So here we have rule 1, which is log base of b m times n equals log base of b to n plus log base. So here, let's write them down in your notes. It's very, very important. You have to memorize these. So say we have log base of, I don't know, 2 to the 4 plus 4, right? So that will be log base 2, 4 plus log base 2, 4, right? And that will be 2 plus 2, which is 4. Oh wait, sorry, messed up here. It's not 4 plus 4.
Yeah.
Yeah, sorry.
It's okay.
Whoops. 4 times 4. Right. Okay. So that's a simple example for that. And then here we can do the same thing. So we have log base 2 parentheses. What? Hold on. Let me write that somewhere else. We have log base 2 parentheses 4/2, right? That will be log base 2 4 minus log base 2, which is 2 minus 1, which is 1. So these might seem really simple right now and seems unnecessary to, like expand them. But these are just like examples, because if you go into harder problems with like bigger numbers, it's very useful. Yeah, so the same thing goes for everything else. And here, if you see any, so this, if you change it, it'll be b equals 0, b to the 0 power equals 1. So any number that's to the power of 0 will be equal to 1, right? Everyone knows that. And then this will be b to the first power equals b, right? Because anything to the first power will be itself. And then here, this one, I can give you example, like maybe it's log, I don't know, to the 2 of 8, right? So you don't know what that is. Then you can change it to log to the 2 to the 3, because 2 to the third power is 8, right? Because 2 to the third power is 8. And then from here, you will see here's b, here's b. So you will know that this answer will be 3. It's right here. So it's just a simple way for you to figure it out. Yeah. And then the same thing applies for everything else. It's just a rule that you have to remember. Oh, and numbers here, m and n must be positive. Yeah. So just write this down in your notes. Give you guys 1 minute to copy it down.
Ethan, do you wanna go over like 31, 32 maybe?
Okay, so for this one, number 31, we'll apply the rules. Number 7, and then as you can tell, there's a 12 and there's a 12 there, which means they are the same, and that they can be canceled. So cross out. And the answer will be 144. That's it. Easy. And for 32, it's the same thing, right? Yeah. It's a 5 at here and 5 over the base, or which I don't remember which one's base, but like they will cancel out and the answer will be 17. So when you see both things are the same, you can cancel out them in log. Like if x to the power of log of the same number, you can cancel out those. And for this one is 72. And this one is not, this one is different. I don't know how
Alright,
to
so for this one, so you guys can see over here we canceled out 5 and a 5, right? Because 5 over 5 equals 1, and a 1 times 17 will equal to 7. Yeah, 17, right? So like that's how you get the answer over here. That's also how you get the answer over here, and also how you get it over here. So when it's over here, we have a 9 and a 3. So when we cancel that out, that will be 2. Wait. Oh, and then 20 to the second power will be 400. Yeah. So here, sorry. Ignore this part. Yeah. So it's really like 17. It's like that. Okay. Let's go to the next page. Yeah, so here are some problems.
Yeah.
Do you want to solve it?
Yeah, okay. So, okay, since I think it shows the answer when you click on the next page, but yeah, but we can just explain this one and then we can like do the first one and second one by yourself after. Yeah, it should be okay. Okay, so first of all, look at this one. You can see that you can like change the 16 and 32 to a same number. So that way you can like cross out the things that you don't need to like care about. So right here you can change 16 to 2 to the 4th power, and then you can change 32 to 2 to the 5th power, which already showing you right here. And then after that you can bring the 4 down to here, so just like this right here. And then right now you can see log base 2 and 2 are equal to 1. And then log 2 and 2 is equal to 1, which match the rules that we learned before. And then you do 4 plus 5. Since 4 times 1 is 1, and 5 times 1 is also 1. So you do 4 plus 5 equal to 9. And then that's your final answer.
4 times 1 is not 1, it's 4.
Oh,
I'm sorry. Yeah, 4 times 1 is 4. I'm crazy today. I'm always crazy. Sorry. Yeah. So you should get 9 at final answers. So yeah, you can try number 1 by yourself. And then for number 2, since here is minus, just remember the rules are like if you have minus, you can change to divide form. So just make it easy as you guys. Yeah, it should be okay right now. So go ahead and try those. Yeah, let's go over the answer with Liz.
Okay, I'm just gonna write it out and then it'll be easier. So here, first one, we have log base 2 to the 8 plus log base 2 to the 4th. So it would be nice if you could recognize these as answers like right away, but it's most likely that you don't. So here, we have to change the argument, right? Because this is the argument. So what we'll get is log base 2 to the 3rd plus log base 2 to the 2nd power. So, and then here, if you recognize our rule from the slides before, this was a B. It's B, and then K, I believe, right? And then there's B, and K. So these two numbers are the same. These two numbers are the same. So we'll be just left with 3 plus 2, which is 5. Right. So that will be a way of solving it. But you can also think of it like if you know, like for me, Tracy and Yvonne, we will automatically know that this is 3 and this is 2. All right, so we'll know it's 5. But if you don't, it's okay. You can just still solve it. Yeah, okay. On to the second one. Tracy already set it up for us. So we will just continue solving. We'll get log 3, 81. All right, because 162 divided by 2 is 81. So realize how Tracy moved these two numbers into this fraction. You can only do this if you have the same base over here, like 3 and 3. If you have different base, you cannot do it. It's illegal. You cannot do it. Yeah, you have to make sure it's the same base. So after that, you can have log 3 and then 3 to the 4th, which then you'll get equal to 4. Yeah. So that'll be how you solve it. But the more you practice, the more that you will not need to do these two steps because you will know the answer from this step right away. But it's okay if you don't know right now. Yeah, I'll show the answers right now. There. Okay, so you can copy these down if you want to have them as a reference.
Yvonne, you wanna like explain it, or you want me to go over?
Can you do it because I don't really understand the E part.
Yeah. So like, let's don't look at this part.
Oh, we can go to the next slide if we want.
Well, yeah, that's okay.
Okay, next, ignore this. Whoever editing the video, cut this part. Okay, on to the next slide. Yeah, Tracy said she understand it, so let's give it to Tracy.
Okay. So basically here is called natural log. So you do the ln thing. is just the opposite from the log. So natural log right here. And then E is just a like letter you using log. And then when you have natural log and E same together, like this one, you can just cross out them and then set is equal to 1. So which always like says right here. And then an example to here is that like so right now natural log E is 1, and then 1 times 2, which is 2. So it's just like some important rules that you need to remember. It doesn't have like special meaning or something, but you just remember the rules. And then right here is the same things. So right here is e to the power of natural log, but it's always the same thing. It's always equal to 1. So 1 to the x. Yeah, no, never mind. It's not equal to 1. You just cancel out. It's just none. And then you bring the x down to here. So same thing as here. You just cancel out the e and natural log here and bring the 7 down. Will be 7. Yep. And then yeah, go ahead.
Okay, so I just want to say something. We didn't cover this before, but you see here, there's no base, right? Like, where's the base? When there's no base, it means that it's the base of 10. Like, that equals to that, and this is log base 10, 1. It's just another notation. If there's no base between the log and the argument, then the base is 10. If there's a base, then that's the base. If there's no base, then the base is 10. Okay. Yeah, that's all I'm gonna say.
Yeah, what about we can let me pause the recording.